So, let's start again with this final track of the SFSCon. So, welcome all of you to this IOTA track. So, this will be a track destined to technologies like blockchain, distributed ledger, and so on. And it will be very interesting to have a look at the latest development in this new field. So the first speaker is Kumar Aniruddha, I hope that I pronounced it well, from the IOTA Foundation, and he will bring a new topic, which is not building apps, but instead building protocols. So welcome, do you hear me?
Yes, absolutely.
Okay, so I leave you the floor for your presentation.
Thank you so much. Hello, everybody. My name is Kumar Anirudh. I'm a developer advocate for IOTA Foundation. This is obviously, the next stage in the evolution of conferences and events that we are seeing right now with these hybrid conferences. Obviously, thanks to the passing of COVID and everything that has already happened so far. So with that, we already have 15 minutes, so let's just get started. So I'm not sure how many of you have already heard about IOTA Foundation or the IOTA in general, or protocols or as such. So I'm gonna go from there. For those of you who have already heard about IOTA or blockchain or decentralized technologies, it might not sound very new things to you. But for everybody else, obviously, welcome to this presentation. I hope I can convey my thoughts pretty well. When I say building protocols for the new world, a couple of things pops up in our head right away. First is, why protocols? Why not apps? Why not mobile apps? Why not web apps and so on? Why not CLI tools and other stuff? And what is this new digital world that I'm talking about? So I'm gonna start from there, and let's see. When we hear about protocols, the first thing that comes to our mind are the usual suspects, the networking protocols, communication protocols, automation protocols, hypertext, HTTP, FTP, and so on. Yeah. And now there's a lot of automation protocols, which has also started popping up, and that has obviously has a huge a huge demand in across industries, especially supply chain and other industries, which has affected it. But when we define protocols, it's just a set of rules, that does a particular task. It can be that it just transfers our packets in a specific order. It can encrypt something in a certain way. It can decode or encode a message, and so on. So there's various types of protocols that we have already encountered in our day-to-day life, in our every technology that we have already that we are already working with. But if you look at the old architecture, so there's still a huge part of our software development cycle even now. And if you look at this, most of our client applications sort of lie over at this layer, where we interact with our devices, mobile, desktop, even the phones or whatever hardware devices as well. And then there's a middle layer in which all these clients try to access the data, and this layer obviously again starts all these different protocols which are there, like the payments protocol, scheduling, queue, and printing, and so on. There's a huge this layer just goes on and on with numerous examples by its own itself. And what we are talking about, the next step in the evolution in the architecture of how our world works, it's actually going from having a central server and our devices trying to access those servers, to having an entire network and every device accessing the data directly, accessing or updating that data directly. So we are not just like, there is no need for now these small brokers which will try to connect our different modules or different protocols together. We are interacting directly with the network, and we are we are getting connected, we are transferring payments is happening in a P2P way. So we are moving a slightly ahead of the curve of where the traditional how the traditional architecture sort of works. And that gives rise to a lot of questions. This gives rise to sort of like what a decentralized apps are, because these are not owned by or any entity, or these are not running on any particular servers. If somebody wants to just update an app, they you can't just go to log into your AWS account and just do a git pull and update the server, and that's all. Get it going from there. You can just update on your network, on your node, and let every node sync up, and only then everybody will be able to access it instantly. So while there are a lot of advantages that is coming up with these things, there's obviously a lot of disadvantages also. Now you will now this entire process of updating is not just dependent on you; it's just dependent on a large amount of networks, which will have to agree that this is an updated version. If they don't agree on that, they will just discard this version and they will keep using the old version, which is a problem, and we can deal with it. But I think it's a very happy problem to have. But obviously, this sort of architecture has rendered or is rendering as we speak the current backend sort of servers obsolete, and we will see more of those. Result is, like, you can see a huge amount of applications which is coming up in every field, starting from finance, from different types of decentralized applications, to the very bottom of infrastructure layer applications. There's protocol layer applications, there's middlewares, there's oracles being born, and so on. And this has just gone on to a whole different level. I think a lot of buzzword has been, a lot of you would have been hearing about, Web3 apps and so on, because that's the current environment, or the current ecosystem that we are living in. And this change is just happening in a super fast way. And before we can blink an eye, every Web2 technology that we have currently is being transformed into a Web3. Everything, like starting from even our domain name system has now a counterpart. So you can have sort of like an ENS or something similar, which will have which will do the exact same thing. So what our domain specifications did, and these are just keeping on evolving. Our current banking architecture is now converted to a crypto architecture, and so on. But it's not just the usage of crypto; it's also that data layer which enables us to connect various entities together. And that goes on from every, like, you can see there's a bunch of developer tools which is coming up. The financial system is getting disrupted. The organizational systems, how we are conducting our business or connecting or managing our data is getting disrupted. We are seeing a huge upheaval in the mode of communications from personal usage of apps and social networking and so on. This has and that is the exact thing that is happening right now. So what will be and this huge infrastructure cannot operate in a closed environment. I mean, if somebody says that you just have to deploy your app at your own node and every node will sync up, we won't be able to trust that system. How would we trust that? Okay, what you're saying is fine, it sounds amazing, but how does this actually work? And for that to happen, that infrastructure layer has to be open source, so that we can verify that, we can authenticate we can verify the authenticity of the network or the infrastructure itself. So that cannot be a closed infrastructure. And if so, any enterprise which is coming up with says this is my infrastructure, and you can, if you deploy in this, it will be this much faster and all. I mean, that's all fine and good, but show me your code. And once it goes that's where our open source technology is really comes into being. And that is where the new age, the digital protocols has to be open sourced, and it has to be an open infrastructure. we can't rely on, like, if somebody says a private blockchain, I mean, what is that? A private blockchain? It's supposed to be decentralized, and I can't really get around that thing. All right, if I'm a part of that, if I'm a part of a permission network, that's also fine. It's a public permission network. I can get behind that, and that is where the enterprise infrastructure of having to trust on a black box system is going away. We are no longer we no longer want to rely on a particular enterprise taking care of the entire aspect of how its protocols and how its infrastructure works. We want to see proof of that. We want to see it being audited. We want to see how the data is being managed, and we want to have our consent going on to where our data is going. We want to have that control, and that's why open protocols is all the more important in this new world. We are also seeing an insane amount of interconnected devices now, and that is like starting from each of us has at least one mobile phone, at least one laptop, or two or three, or there's the devices with the Raspberry Pis and Arduino's. There's Alexa, there's Google Home, there's Google Nest, whatever it's called, and this insane amount of Fire TV Stick and so on. There's insane amount of connected devices right now, and all of this data is now flowing into this infrastructure, which is right now so close that we are not even aware of what's happening behind it. That is going to change super, super fast, and we're going to see a world where everything that is connected is and has to become an interoperable, which is actually the biggest concern of how it's going to be conducted, of how it's going to conduct itself. And no one platform can support everything, So it has to be a world where everything is interoperable amongst itself. So the new protocols for the Web3 world has to be, open protocols in which we can, in which we can all collectively build the solutions for. We don't need 100 different solutions. We need one solution, and 100 of us can work on that. That is the exact definition of how the open source software work, isn't it? And these softwares can now be run using smart contracts, which will run on these decentralized networks. So everything is actually out in the open, and that's where I come on to building protocols on DLTs, because how do you build these protocols? I know I might be going a little too fast. I will be sharing this presentation as well, so there's no need. If you're missing out on something, don't worry about it, because we have a little less time. That's why. All right, so going back to this, how do you build your own protocols on these decentralized ledger technologies? These decentralized ledger technologies are already giving you the infrastructure, giving us the network and the tools to actually build on top of it. All we have to do is define what we want to build. Even the UI and UX, it's up to us to design. The device is already in front of us. We have the mobile phones. All we have to do is encode what values or what is a formula that it has to that has to go through to actually get to that to get to that aspect. Even the identity authorization and everything, there's decentralized identity and which can manage without any other third party getting involved, and which is the most amazing thing about this about open protocols now. Talking about decentralized identity, you don't need any third-party verifications or authorizations to go ahead. And there's an example here of how it might work. Let's say if you want to interact with your bank, and you will have a browser actor, a desktop actor, and how it will just connect and work in between. This is obviously an example showcasing the IOTA decentralized identity, and which is an amazing technology by itself. And the code base is also open source. You can find that out on the IOTA Ledger GitHub repository. And with that, the next step of evolution is obviously the IOTA smart contracts architecture, and not just IOTA smart contracts, it's any smart contracts architecture. The world has to be interconnected. Like I said, it has to be interoperable between various different protocols. And That's where now imagine that the network is already there. All we have to do is write one smart contract and just deploy it. Anybody can use it. We can just share that address to somebody and they can just start using it. Let's say I want to write or start my own escrow product. So I can just write an escrow smart contract. All right, I hear the bell. So I'll just wrap up very quickly. I can just write an escrow smart contract. I'll give you the address, and you can just interact using that. And the ID will be your wallet ID and your decentralized ID. So the open source, like I mentioned before, open source protocol is built on the future. That is the world infrastructure. It depends on on protocols that we write, and it has to be open. Thank you so much. Apologies for rushing in. I hope I managed to catch most of it.
So thanks a lot, Kumar, for the very nice presentation. Fascinating to see how much this technology will disrupt the current implementation that everybody has done. So thanks a lot, and we are going to start with the next speaker in 4 minutes. So this means 12 at 20. Thanks.
Thank you so much.
Okay, so let's start again with the next speaker, Stefano Della Valle from the company Teleconsys. And let's introduce an aspect that was somehow introduced also in the previous speech. So what's about also with these new technologies applied to the IoT world? The floor is yours.
So welcome everybody. I'm Stefano Della Valle. I'm in charge of DLT data competence center inside of Teleconsys. And we're talking about DLT, we really talk about IOTA. Today I will explain an idea that we are working on regarding a distributed IoT platform. Surely you have seen this data many times. Huge number of devices connected, huge number of investment and projects. What probably you haven't seen so much is the cost of the cyber attack on IoT infrastructure and IoT-based production plant and process that we will see in the next year. We are talking about 10 trillion annually of cost. It's a very huge and impressive amount of money, and this is something that I would like to try to solve. I've collected some magazine titles just to have an idea that this is a very, very long, widespread phenomena. We have attack on water supply, iron production, transportation, grids, electric grids. Even a ski pass was open to attack on the internet. We have some small clue of this critical problem and the root cause of this problem, even from SolarWind and Microsoft SolarWind platform that has been attacked years ago, and we are still finding effect of this attack a year later. Another, of course, clue on where is the root cause of this problem gave us from the Facebook outage some weeks ago. So where is the problem? The problem, from my point of view, is that in the last 15 years, technology has been growing very fast, and we solved many critical points in terms of the reliability of our platform, moving much of this platform to the cloud computing. Cloud computing solves the single point of failure critical problems, but open another critical point, the single point of control. You can see, you can imagine the effect of having an attack on IoT devices that will be the source of information that will be used to train an artificial intelligence. And you can imagine the effect on the efficiency of this artificial intelligence. So it's a very critical point, even for other technologies that can be involved in the process. The best practice are not solving, because the idea is to close and wrap everything inside of a bubble, a security bubble, but this is not actually possible, because there are a lot of components that need to be open to external interaction. We need to grant data access to the third party. Devices, of course, are physically manipulatable. The platform is managed by third party, and of course the human factor is out of control, mainly for privacy reasons. So where are the operational risks? We have more or less four huge points of risk. The data theft, of course, is the first of them. The risk of platform outage and the fake data injection in the platform. And also we have the side effect of everything, this point, the outage of the plants controlled by the IoT platform itself. Where is the clue? Where is the root cause of the problem? The root cause, from my point of view, is that we forgot the origin of the internet. The internet being designed to be a distributed architecture without a critical single point of failure that could impact all over the infrastructure itself. Then we moved slightly to decentralized infrastructure and architecture when we started using some years ago the VPN as a method to isolate but connect some branches of our company. And then finally, we moved everything in a very centralized architecture, the cloud computing infrastructure. Actually, DLT, blockchain, and even the decentralized autonomous organization are totally distributed. And so this is probably the best solution to solve whatever I already showed. This is why we are working to build a decentralized IoT platform that can be really, really secure. And of course, the idea to start designing this solution is to leverage on the decentralized architecture. So we used 4 main components. The first is the decentralized identity that grants to identify things, people, and also organization in a very secure way. We will build a device able to grant a root of trust, so something that can be not physically tampered with. And of course, we need also a transport layer that should be very reliable. And to do that, we decide to use the DLT as a transport layer. And finally, of course, we need an unstoppable supervisor platform that will replace the central application features and grant the same level of service. So basically, we are moving from a centralized architecture in the IoT platform where the data consumer and data producer are intermediated by a supervisor platform to a platform where everything is able to communicate directly end-to-end. So we will have a data consumer and data producer able to communicate over a reliable transport that is actually the stream channel that is the blue line there. This supervisor itself is a component of the architecture, but is not intermediating any communication or any data exchange. The root of trust is a very important part of this architecture, because if we have no central point where some sort of validation can be done before to distribute the data, we have to grant that the data are secure and valid since their origin. So we are using this device that is a special version of STM32 system on chip or microcontroller that is able to create a trust zone in its internal hardware architecture that will operate and grant all the information that need to be signed before to be able to be published. So whatever comes out from this device is totally unbreakable because already signed inside of a trust zone. Then the secure transport is the stream protocol. The stream protocol is a proposal from IOTA Foundation. It works on IOTA, but it actually can work on whatever. We, of course, prefer IOTA because it's the only DLT able to grant performance, cost, and also it's free of any charge to write information inside of the network. And this is why this transport is very efficient. It can be used for this scope. The goal of this transport is to grant that the communication from data producer and data consumer is totally asynchronous. So there is no need to be connected directly. And the very advantage is that the data is totally not related to a geographical position or something that can allow to understand where is the data source. The usage of the identity, distributed identity, grants another additional features in this architecture, that is the possibility to use a verifiable credential. This means that the devices can become autonomous in deciding to provide information to a third party without to have to interact with the supervisor. they can verify the verifiable credential provided from the device owner or the supervisor to a third party, and then decide if they are valid. The unstoppable supervisor engine, the last component, and this is the very innovative part, because the supervisor engine is a sort of ghost component able to receive data from the trusted device, evaluate the operation status, and publish a sort of opinion on the data that the device is producing. So we have a sort of quality quality information that can be evaluated by the data consumer and come from a supervisor trusted engine. Trusted why? Because at the end of the development process, this component will be a smart contract, and so any kind of tentative to manipulate the supervisor engine behavior is, of course, impossible due to the nature of the distributed computing that support the smart contract itself. So at the end, I have a very list of some benefits. We have a very low-cost infrastructure thanks to the IOTA distributed ledger that support the secure transport layer. We have a security identification of every component. We have the ability to delegate devices to execute critical operation without risk. We have a reliable and unstoppable component and infrastructure, a supervisor infrastructure. And we have a lot of security and privacy because everything can be encrypted and published only with an encryption that grants only the correct receiver to decrypt the information. So it's a very innovative solution that we will hopefully fully available next year. Thank you for listening. This is my contact. Whatever information or question you want, please feel free to contact me. Thank you.
So thanks a lot for your presentation. We have still a couple of minutes. Maybe there is some question from the audience? No? If not, I would say thanks a lot. And we will start at 12:40 with the last speaker. Thanks. Okay, so let's start again with the final speaker of this track. So let me introduce Nicola Altamura from the University of Rome, La Sapienza, and he is going to present us the latest developments regarding the application of the IOTA solutions on embedded devices. Nicola, can you hear us? Okay.
Yes, I'm Nicola Altamura. I'm a PhD student of Sapienza University. And solution for addressed to embedded devices. In particular way, the solution uses the IOTA MIM and the IOTA Tangle. Okay. Okay, so can you see the presentation?
Wait a second, because, okay, now yes, you can start.
Okay, okay. So this work proposed a new secure communication protocol specifically addressed to low-level devices, particularly for underwater environment. The Internet of Things practically is based on integration of various devices that support different processes with the aim to detecting, networking, computing, and identifying. We want focus on Internet of Underwater Things that can be seen as a specific application of Internet of Things, but this technology has more restringent requirement under the point of view of energy computation and limitation of devices. And the classic communication model and the protocol are not suitable for the underwater environment practically. Different are the motivation and the problem. There are still several unsolved in these domains. In particular way, there are security problem related to poor resource devices, not suitable protocol, and the lack of security in the Internet of Underwater Things solution. In addition, this practically the lack of security-oriented solution make the network, this network particularly vulnerable. The second reason concerns the lack of security in relation to the growth of the Internet of Underwater Things and the Internet of Things infrastructure, and this increase the available attack surface and the associated vulnerabilities. Finally, we see that the problem of interoperability makes the communication between different network and the external application impossible and very difficult. This due to the custom solution and the heterogeneous devices in this kind of network. Our solution aims to solve some of this problem, and to understand our work is necessary to present two protocols provided by IOTA. These two protocols are the IOTA Tangle, practically the distributed ledger technology, and the masked authenticated messaging. The IOTA Tangle is a distributed ledger technology provided by IOTA. Is maintained, is decentralized and distributed. Is this solution working on multiple nodes and has no central authority. Not is a classic blockchain structure because it's a direct acyclic graph, and in addition provide also additionally properties like scalability, transaction speed. There is no dichotomy among the nodes because there are no miners in this network, and the scalability and transaction speed increases as transaction increase, and with the increases of number of nodes directly on the network. The second protocol is the masked authenticated messaging. That is the protocol that guarantee a secure stream directly on the Tangle. It allows to create an encrypted and authenticated stream on Tangle, and it uses a cryptographic and signature algorithm to ensure privacy, authentication, and integrity. Now we present our solution overview in a conceptual way. We're using the technology provided by IOTA, and we want to create a new communication solution addressed to low-level devices in this kind of network infrastructure, in particular way in perception level. In this way, first of all, we want to guarantee communication security, communication in security, such integrity, privacy, and authentication through encryption and signature algorithm. In this case, with the thanks to MAM protocol. Instead, thanks to the use of the Tangle, we obtain interoperability, integration, and standardization in the data exchange process. We therefore exploit the characteristic of the IOTA protocols to create a secure and interoperable protocol. For the implementation of this protocol, we started from a feasibility study. We analyzed the software requirement and the device capability in order to make this solution suitable for the target devices. We then started with the reverse engineering process, and particularly a careful understanding of the logic through functional analysis has allowed us to extract the most important feature of the MAN protocol in order to make this protocol suitable for the target devices. We have therefore rewritten the logic in the library in the C language, with particular attention to the cryptographic library, in order to make this solution executable on the low-level devices. Once the code in C was completed, we verified the correctness of the payload with a syntactic verification method. And in the last step, we then imported our code into embedded environment. To do this, we have integrated our MAM.C protocol with IOTA.C client library provided by IOTA for embedded devices. We then ported everything on a test board and ran the code. Finally, a message was successfully created and forwarded directly on the Tangle from our test board. This is an overview of internal system architecture. There are two main components that are MAM protocol core IOTA client.c. In this case, MAM protocol provides the functionality for the creation of payload, and IOTA client.c guarantee provide the functionality and the library for the communication with the Tangle. All these two protocols are supported by RTOS, real-time operating system, in way to and this RTOS guarantee functionality like communication protocol and support cryptographic functionality. Practically, this is these two protocols interact with each other in order to provide the final support the final objective. The whole project was developed and tested on a disk test board. This test board is equipped with the ARM Cortex M4 with 2 MB of flash memory and 604 KB of RAM. And we can see some results. First of all, the compiled result. In this case, the size code in RAM memory and in flash memory. And the code size seems suitable for the test device, but also for many sensor nodes. The second important result showed the interoperability between two different kinds of devices. In this case, our test board that detect the data, in this case temperature data, and send this data directly on the Tangle. A second device, in this case Raspberry Pi, with a JS client, fetch the data directly on the Tangle, directly from the channel opened by test board. The table showed the execution a computational test. We showed the time the time needed to create a MAM payload message is around 18 seconds. In this case, two different parameters are set. In this case, the security level is 1. And the mode that, in this case, there are 3 different modes, public, private, and restricted. Only in restricted mode, it uses a encryption key. And practically the execution time is strictly related to security level and access mode, practically the privacy mode. We did also some energy test. The first lab test showing that energy consumption is around 118 milliampere, but this result is conditioned by some board setting, like enabling peripherals and debug mode on. The second evaluation is a theoretical one. In this case, the simulation is set for under certain energy profile. The code ran for 18 seconds around, and for 1 minute, is the board was in sleep mode, in a low energy consumption mode. The results show a more adequate consumption and estimated duration that is for more than 1 year practically. Finally, we want to propose an IO underwater things architecture solution. In the perceptual level, we find our underwater object with the purpose of detecting and reacting. In this case, the device can open a channel on the tangle and can write the data detected directly on the channel. Any other entity, such as server or ground station, can read the data directly from a channel. The server, on the other hand, will write a new instruction on its channel, which will be read by an actuator in the perception level. The actuator will take corrective measures. Finally, we can say that our solution supports and fulfills the intended objectives. We can see that our protocol ensures security in the sensor network, guarantee interoperability with different devices at application level, is IO underwater things IoT suitable because few resources are needed, and is architecture independent because there is not need for fog level or integration level, and is not topology dependent. As a future goal, we want to optimize the code for the point of view of energy and computational performance. We would like to ensure greater integration with other family and other board and other sensor node. And we want to make this protocol useful and in order to supporting the business objective and add the machine learning and data analysis solution to our solution. Finally, we want to add the IOTA identity, a protocol for distributed identity directly on sensor node, with the aim to improve the overall security network level with a new security framework solution. Thanks you all for your attention. If anyone has any question, I will be glad to answer.
So thanks a lot, Nicola, for your contribution. I would like to ask you if there are any questions from the audience. No? So if not, I would like to thank you again. And with this presentation, let me close this track and also the conference, since we are now at 1 o'clock. So thanks a lot, Nicola. See you next time and next edition of SFESCO maybe. And so thanks a lot everybody for your participation here at Neutech Park and remotely. And let me close this track and the conference. Thanks.